So the question asks you to find delta H for this reaction right here, given that you have these two reactions beforehand. Well, if we want to do that, we want to get the reactants and the products on the proper sides for these reactions. So we have N2O5 in the products here, and we have N2O5 in the reactants here. So let's flip this reaction around and also flip the sign for this delta H. So if we rewrite this, we have 2NO plus 3 halves O2 will give us N2O5. And the delta H for this reaction, since this is positive, is going to be a negative 223.7 kilojoules per mole. All right, so we got N2O5 out of the way. That's checked off. Then we have NO2 in the reactants. Well, we have NO2 here, but it's in the products. So we want to flip this one around. So we got NO2 gives you NO plus 1/2 O2. The delta H for that, since this is negative, is going to be positive 57.1 kilojoules per mole. Now the thing is, the coefficient for NO2 in our actual reaction is 2, and we only have 1 here. So we have to multiply this whole thing by 2, and that means we also have to multiply this whole thing by 2. So this gives us 2NO2 gives us 2NO plus O2, and the delta H for that will be 114.2 kilojoules per mole. This is positive. Now, if we add these two reactions together, so if we add this and this together, we're going to get our final proper reaction. We would get 2NO2 plus 2NO plus 3 halves O2 gives us N2O5 plus 2NO plus O2. Now, if we see things show up on both sides, like NO to 2NO and 2NO, you cancel these out. And since we have 3 halves O2 here and O2 over there, we can cancel it out, and this becomes 1/2. And then this basically finals out to become 2NO2 plus 1/2 O2 gives us N2O5, right? Now the delta H for this is going to be these two added up. So negative 223 plus 114.2 is going to give you a negative 109.5 kilojoules per mole. So finally, the delta H for this answer is negative 109.5 kilojoules per mole.